Today, we're going to talk about something pretty fundamental. Building a digital world where truth isn't just a promise, it's something you can actually prove with math. And it all revolves around this idea called the atomic kernel.
I mean, think about it. We spend so much of our lives online, but that whole world is kind of built on digital sand, right? Files get copied endlessly, history can be quietly erased, and your data can just disappear. So it makes you wonder, can we really build a digital world that we can truly, deeply trust? But what if we could fix that? Just imagine, what if that unique sword you won in a game was actually provably one of a kind, not just another copy-pasted file? Or what if a digital receipt for something you bought was totally unforgeable? Or if you had a complete, verifiable timeline of your own personal data? This isn't just sci-fi talk, it's the whole point of building a new kind of digital foundation.
So, how in the world do we get there? Well, the answer isn't just to add another security patch or even to rely on existing tech that just tracks transactions. The real answer, it turns out, is to start from the very beginning. With a system that's so predictable, you can prove how it's going to behave using pure mathematics.
And at the very core of this provable world is something you can think of as an unchanging digital heartbeat. This is what we're here to talk about, the atomic kernel.
So the main principle here is that the kernel is what's called a deterministic system. Now, that sounds complicated, but the analogy is super simple. Think of your favorite movie. Every single time you press play, the exact same story unfolds, right? The kernel does the same thing for digital actions. The same input will always produce the exact same output. No exceptions, no surprises.
And here's the best part. This isn't some company just saying, hey, trust us, our code is good. This predictability is baked in. They call it kernel law. It's like a constitution for the system, and it's all verified by machine-checked mathematical proofs. The math itself is the guarantee. This quote from the documentation really says it all. The math is the ultimate boss. If the software that's actually running, the runtime, does something that goes against the mathematical proof, then the software is considered broken. Period. The law doesn't bend for anyone or anything. Okay, so having a perfect mathematical law is one thing, but how is it actually enforced? How do you make sure everyone follows the rules? Well, that's the job of the kernel's guardians of truth.
The system uses this awesome three-part defense called the verification triad. So first, you have the proofs. That's the mathematical contract, the rule book. Then you have gates. These guys are the enforcers. Think of them like bouncers at a club. They check every single operation, and if it violates the law, it gets rejected. And finally, replay locks make sure that an object's history can be perfectly replayed, basically setting its past in stone. So when you put all three of them together, you get this incredibly powerful defense. They stop systems from secretly changing over time, they prevent anyone from messing with historical records, and they stop apps from trying to grab more power than they're supposed to have. Now, with these safeguards locked in, the system can finally tackle one of the biggest headaches online, creating a digital identity that simply cannot be faked. This is how we start to prove what's real. The kernel does this by creating two different types of identity. First up is the SID, or semantic identity. The best way to think of this is like a unique birth certificate for a digital object. It's made once, and it can never change. Then you have the OID, or occurrence identity. This is like a new line item in that object's permanent record every single time something happens to it.
So here's how they work together, and it's really clever. The SID is a cryptographic hash, basically a unique fingerprint of the object itself. Then each new OID is another hash that combines the original SID, a timestamp, and the OID that came right before it. What you get is this unbreakable append-only chain of history. If you try to change even one tiny thing in the past, the entire chain would shatter, making any tampering instantly obvious. All right, so we've gone through the deep tech, right? The deterministic kernel, its guardians, the identity chain. But now let's get to the really exciting part. How does this trustworthy core actually let us build those cool consumer apps we were talking about earlier? It's all about layers of authority, kind of like a government. At the very bottom, you have the kernel. That's the constitution. It is unchangeable. Then you have the runtime. That's like the police force, making sure the law is followed. On top of that, developers can build extensions, which are new apps that must obey the law. And finally, you have projections. That's your personal window into the data. And you can look all you want, but you can't change the underlying truth. This whole concept is called authority separation, and it is absolutely critical. It means an app, like a metaverse game or a digital wallet, can take advantage of the kernel's guarantees of truth and identity, but it has zero power to rewrite those rules. It can't counterfeit an item. It can't erase a transaction. It simply doesn't have the authority.
So let's bring it full circle. Remember those possibilities? That personal manifest is just your own secure projection, a read-only view of your digital life that can't be secretly changed. Those unforgeable genealogy receipts? That's just the SID/OID chain giving any digital item a complete, provable life story. And that unique metaverse sword? Well, now we know its SID is its birth certificate, and its OID chain is the undeniable proof of its history and who owns it.
So here's the big takeaway. Trust flows upwards. Because the kernel at the very, very bottom is mathematically true and unchangeable, any app built on top of it automatically gets that same level of trust. The foundation is solid, so the whole building is solid too.
And that leaves us with a really powerful question to think about. For years, we've just gotten used to a digital world where things can be faked, forged, or deleted. But if our core systems become provably true, what lies will we just no longer be willing to accept?